In this video, I would like to go over some of the major concepts in section 4.4 of our textbook. One major concept is to find all 6 trig functions, given that the angle could be in any of the 4 quadrants. All right, let's take a look at the following example. So let's say that they give us this point right here. And with that single point, I'm going to show you how to evaluate the all 6 trig functions here. Okay, the first thing to do is let's try to figure out what quadrant this point is going to be in. So we go -4, 1, 2, 3, 4, and we climb up 3, 1, 2, 3. And so the point is in the second quadrant. Okay, that's going to be important for finding the correct sign of our answers. So what makes 4.4 different from 4.3 and before is that we're still going to find the all 6 trig functions, but this time some of our answers are going to be negative, and it has to do with the quadrant. Okay, so let's just write down that it's in quadrant 2, and that the signs are going to be negative for cosine and positive for sine, and of course tangent, which is defined as y over x, is going to have, let's see, we're going to have a positive divided by a negative. So that means that tangent will be negative. All right. The next thing we do is we're going to draw a triangle. And this right triangle is going to be as simple as possible. I'm going to use this x value and this y value to start labeling my triangle, except that I'm going to use only positive values. So the x is the -4, and I'm going to put the 4 here, but not a -4, just a positive 4. Once again, this is going to be as simple as possible. So positive values only. Okay, and the y is going to be the vertical part of this triangle, so that's going to be a positive 3. And with the use of Pythagorean theorem, I'm going to find the missing side here, and it's going to be 5. So let me get back to the problem here. So now we find cosine. And for cosine, we're going to get that cosine is equal to adjacent over hypotenuse, or 4 over 5. But once again, because we are in quadrant in quadrant 2, and quadrant 2 has an x value of -4, we're going to say that cosine is negative. So our answer here for cosine is -4 over 5. Once again, cosine is negative in the second quadrant. Okay, let's move on. Secant is the reciprocal here. So the reciprocal is going to be 5 over 4, but the sign is still negative. All right, so the function and its reciprocal will always have the same sign. All right, moving on. Let's find sine theta. Sine theta is opposite over hypotenuse, or 3 over 5. And let's see what happens with the sine here. Well, for sine is positive in quadrant number 2. So then that's positive 3 over 5, and its reciprocal is equal to 5 over 3. Positive again. All right, moving on. Tangent. Tangent is opposite over adjacent, or 3 over 4. And what's going on with tangent? Tangent will be negative in this quadrant. Quadrant 2, tangent is negative. So it's negative 3 over 4, the answer that we want for tangent, and its reciprocal cotangent is negative 4/3. And that is it. All right. Another concept in 4.2 is to evaluate one of these given an angle. So let me review that. I'm going to erase everything here. All right, so example 2. Let's say that they ask us to do secant of the angle 5 pi and to find the value of that. Well, one way is to use the calculator and get an approximation. A second way to find the exact answer, which is, by the way, most of the time what I'm going to ask you to do, you have to use the unit circle. All right, so the way to do that is secant of 5 pi has a value of, let me see. Well, secant of 5 pi, where is it? Where is 5 pi on the unit circle? Let's see. 2 pi, 4 pi, 5 pi. So 5 pi happens to be coterminal to pi, and this is the parentheses that I'll be using. Okay, well, here we have a parenthesis of negative 1 comma 0, where cosine is negative 1 and sine is 0. Now secant, what is secant? Well, if we go back to our trig functions here, we see that secant is the reciprocal of cosine. So let me write the reciprocal there. And cosine of 5 pi, I can figure that out. It's the first coordinate point. Cosine of 5 pi is negative 1. And so secant of 5 pi has got this answer of 1 divided by negative 1 is negative 1. Let's find what if they had asked us to do cosecant of 5 pi? Okay, well, the reciprocal of cosecant is cosine, or sorry, sine. That's a sine, 5 pi. So let's take a look at the same parentheses, but now let's take a look at the sine, at the y value. So now we're going to get that it's equal to 1 over sine of 5 pi is 0 here. Okay, well, what does this fraction simplify out to? Well, because 1 divided by 0, because we have that, and we can't ever divide by 0, we say that there's no solution here. There's no solution. Okay. Let me do one last example. Let's say that they tell us that secant of a particular angle is equal to 3 over 2, and that they ask us to find the 6 trig functions. Okay, well, the way to do that is to set up a right triangle, and then once we have a right triangle and we have it labeled, then we can find any of these pretty quickly. So let's take a look at this. Secant is equal to 3 over 2. Well, I want to do SOHCAHTOA but I can't do it with secant. So I'm going to use the fact that the reciprocal is cosine. The reciprocal of secant is cosine. And it's going to have a reciprocal value here. It was 2/3. And I'm going to use that cosine is equal to 2/3 to set up my right triangle. So here I have adjacent over hypotenuse. And then I do Pythagorean theorem. X squared plus 2 squared is equal to 3 squared. Or x squared plus 4 is equal to 9. Or x is equal to the square root of 5. Right there. Okay. So now, once we have this right triangle, we can find cosine, sine, tangent, the way we've done in the past. So for example, cosine will be equal to 2/3. Its reciprocal secant will be 3/2. Sine will be square root of 5/3. Its reciprocal will be 3/square root of 5. Simplify that, 3 square root of 5/5. Tangent is going to be radical 5/2, and its reciprocal cotangent is going to have a value of 2/square root of 5, or 2 square root of 5/5. Okay, and so those are some of the major concepts in 4.4.